Here goes a video on powers, roots, and radicals. So what we have here is a little warm-up. What's the square root of 4? I hope you know it's 2. What is the square root of a negative 4? Well, it's an imaginary number, so we're just going to say that it's imaginary. I know it's 2i, but we're just going to say it's imaginary number because we're not going to be working with imaginary numbers much this chapter. What is the cube root of 8? It's 2. What is the cube root of a negative 8? It's negative 2. So you can take odd roots of negative numbers. Think about it. What's a negative 2 times a negative 2 times a negative 2? It gives you a negative 8. However, an even number of negatives will always make a positive. That's why we really can't take the square root of a negative number. 3 squared is 9. Negative 3 squared is 9. 3 cubed is 27. And a negative 3 cubed is a negative 27. Again, it's with that even power. So a negative 3 times a negative 3 brings you to a positive 9, but a negative 3 times a negative 3 is a positive 9 times a negative 3 brings you to a negative 27. Okay, so just make sure you know the difference. So now we're going to talk about radicals. So we're going to learn how to manipulate radicals and exponents. There are a few different forms. So the nth root, this is the index of your radical. As of right now, all you've really seen is square roots and maybe cube roots. But we're going to take it beyond. And then the exponent would be just the exponent of whatever term you're trying to take the root of. So there's two different ways you can write it. You can write it as the nth root of a to the m, or the nth root of a raised to the power of m. Doesn't really matter. Either way you look at it, the m is the top of your fraction exponent, and the n, your index of the radical, is the denominator of your exponent. So, being able to manipulate radicals and exponents is very, very important for the rest of this chapter because you're going to want to be able to flip back and forth. So, what this section is doing is just practicing writing as an exponent. So we have 11 to the first power. So 11 to the first power would be 11 to the, this is our numerator, and the index is our denominator. So we have 11 to the 1/3 power. Now, this next example is able to be simplified, but we'll talk more about simplifying later. Right now, I just want you to practice writing. So, this 4 squared, fourth root of that, we have our numerator, our denominator. This would be 4 to the 2/4. Yes, that could simplify to 4 to the 1/2 because that fraction can be reduced, but for right now, I just want you to practice writing. So you try the next two. And you probably got 8 to the 2/6 power. And you probably got x to the 1/3 power because that anything without an exponent has an imaginary exponent of 1, and you would be good to go. So now, how do you work backwards? Well, remember, the top is your exponent, the bottom is your index. So this is the square root of 5, or the square root of 5 to the first power. You do not need to write a 2 for an index. You do not need to write a 1 for an exponent, but if you want to while you're getting used to all this, that's totally fine. However, the correct answer is just the square root of 5. This next one, we have 6 to the 2/3. So that is the cube root of 6 squared. And this last one is the 5th root of x cubed. And that's it. You're good to go. So let's move on. Let's evaluate. Calculator is helpful for if you can't figure them out on your own, but if you understand all these radicals, it'll make a lot of the simplifying easier. So let's see. What is the cube root of 8? We know the cube root of 8 is 2, but there's another way you can write it. The cube root of 8 can be rewritten as 2 cubed. So look, cube root cancels out a cube, bang, you're left with 2. It's another way you could do it, okay? The cube root of a negative 27, earlier we said that's negative 3 cubed is negative 27, so your answer is negative 3. 16 to the 1/4. If you're not used to thinking about it that way, you could always rewrite it as what's the 4th root of 16, which would be 2, because 2 times 2 times 2 times 2 is 16. So how did I do that without a calculator? Well, good old-fashioned factor tree. If you needed to, if I didn't allow you to use a calculator, it would just be 2 and 8, 2 and 4, 2 and 2. You're done. And since it's 4th root, you circle 4 at a time. So that's just another way you can do it. Or, of course, if you're allowed to use your calculator, you just use your calculator. So what would 4 to the 3/2 be? Well, how about we write that in a different way? What if we were to rewrite this as the square root of 4 raised to the 3rd power? Just rewrite it as a radical. We know the square root of 4 is 2, so 2 cubed is 8. Done. That's all it takes. If you wanted to do it the other way that we've written them, that would be the square root of 4 cubed. What is 4 cubed? 4 cubed is 64. What's the square root of 64? 8. So it doesn't matter which way you want to rewrite it. And of course you don't need the 2's, but if you feel better with the 2's for now, you can go right ahead and put the 2's as your index. Remember that a negative exponent does not mean a negative number. It means you're taking the reciprocal. So this became 1 over 8 to the 2/3 power, which is 1 over the cubed root of 8 squared. And it doesn't matter which one you want to do first. So the cube root of 8 is 2, so that's 1 over 2 squared, which is 4. Now, all 6 of these could have been done with your calculator. So if you have good calculator skills, you can do those right away, right in the calculator, and you'd be good to go. But if you can work with these without a calculator, it's just going to make the simplifying once we get there a lot faster and easier. Okay? So let's move on. Now we're going to solve. Now that you know how to take cube roots and square roots and raise things to fraction powers, we can solve again. How do you get rid of an x cubed? You take the cubed root. It's just like how do you get rid of an x squared? You take a square root. How do you get rid of a cube? You take the cube root. So you're left with x is equal to 3. And you're done. The next one. First, we're still solving, so we got to divide everything by 3 first. Then you get x to the 4th is equal to 16. How do you get rid of an x to the 4th? You take the 4th root of both sides. And if you said that you get x equals 2, you would be incorrect. The reason why is it's plus or minus 2. Remember what we said about evens. Negative 2 times a negative 2 times a negative 2 times a negative 2 is also a positive 16. And of course, so is 2 times 2 times 2 times 2, which is a positive 16. So just like back in the day when we were solving with square roots, we had to remember the plus or minus. That applies to any even root. So anytime you have an even root, you want to make sure you do that. Next example. That's going to give us x cubed is equal to a negative 8, and you are allowed to take the cube root of negative numbers. So you take the cube root of both sides, and x is equal to a negative 2, and you're done with that example. So this next one, this one's a little bit tricky because you have to take the 4th root of both sides again. So that's going to give you an x minus 2 is equal to a plus or minus 3. So now you have to add 2 to both sides, and this is going to take you back to chapter 5. So x is equal to 2 plus or minus 3. You do not leave it that way. X is equal to 2 plus 3 is 5, and 2 minus 3 is a negative 1. So make sure if you have 2 values, you give both values. And the final example for the solving portion, First thing you need to do is divide both sides by a -3. So that's going to give you an x plus 4 to the 5th power is equal to a -32. Take the 5th root of both sides, and you get x plus 4 is equal to a -2. There's no plus or minus with odd roots. So you just subtract 4, and you get x is equal to a -6, and you are good to go. So that's solving. So that is solving. All you have to do is what you did back in the day with square roots. Now you just have to be able to apply any other root. Finding the nth root of a, if I ever ask you to find the nth root, that means the n is your index and the a is what goes inside. So what is obviously the square root of 16? You would just say 4. And what is the cube root of a -27? Well, we already know that's a -3. So how do you use that calculator of yours? There's a couple ways you can do it, but I'll just show you the easiest way. Take the inside. So you have a -27 and raise it to the 1/3 power. There is a cubed root button, but you have to press the math button. There's no 4th root button, so you have to use another couple of buttons. However, if you remember that radicals are actually exponents of the fraction flavor, all you need to do is use your exponent button. So this would just be 16 raised to the 1/4 power. And this would be 25 raised to the 3/2 power. And for this one, your calculator should have given you a -3. For this one, your calculator should have given you 2. And this one, your calculator should have given you 125. And that's it. So you just had a little bit of practice of working with radicals and powers and roots. So being able to apply this to anything else in the next couple of lessons is going to be very helpful. So make sure you know how to go from exponents to radicals, radicals to exponents, simplify, use your calculator, solve, all of that, and you'll be good to go. This is Longo, and I'm out. See you, bye.